Hi, my name is Anna Jagodin, and I am going to be doing my project on the radian and degree conversion. So some simple equations and expressions that are commonly used in the radian degree conversion are, first, we have pi radians is equal to 180 degrees. So that is essentially half of a circle. And to reach the full circle, you have to multiply the half by 2. That's why 2 pi radians is equal to 360 degrees. And now, as pi radians are half of a circle, pi radians are half a revolution of a circle. And again, to reach the full circle, you must multiply by 2. That is why 2 pi radians is the full revolution of a circle. So now that we know these facts, let's go to example 1. So using the information, we have to convert 90 degrees as pi radians, essentially using this information. So we're going to start off by writing down what we know. So what we know is we have 180 degrees, and it is equal to pi radians. So we're going to write 180 degrees is equal to pi radians. And 90 degrees is half of 180 degrees. So what can we do? We need to we're going to write 180 degrees over 2 is equal to 90 degrees. So now we're going to go down, and we're going to do step 2. And we're going to substitute what we know in this equation that we have. So we're going to go down, and we're going to write 180 degrees again over 2 is equal to 90 degrees. So now, using this equation we wrote up here, we're going to substitute this 180 degrees for pi radians. So we're going to write pi radians over 2 is equal to 90 degrees. And to make this more readable is we're going to take radians outside of this equation, this fraction, and we're going to put it right here. Pi over 2 radians is equal to 90 degrees. So what we did is we used these equations above to convert 90 degrees to radians. And this is correct, but you can find a lot of points on the circle, whether radians or pi's, by using a simple fraction. And right here, pi radians over 180 degrees. And we're going to use this fraction that we now know to convert 90 degrees to pi radians once more. So we're going to convert degrees to radians, but we're going to use this fraction instead. And this is supposed to be a more easier way to convert degrees to radians. So what we're going to do is the same step. We're going to evaluate what we know. And we're going to start off by just making sure we know what step we're doing. And now we're going to start. All right. So what do we know? We know that we have 90 degrees, and we're going to multiply it to this fraction right here. So we're going to put the numerator first, pi radians, over its denominator, 180 degrees. And since we're dealing with fractions, I would usually put a 1 under here to avoid any confusion. So now we're going to go down to step 2, which is multiply. We're going to make sure we know this step. So now we're going to go down to step 2, and we're going to multiply this. Right, so let's start by cross-canceling. So let's cross-cancel the unit first. We have 2 degree symbols, so we're going to cross out these degree symbols to get them out of the way, because essentially we want radians in the answer, not degrees. So now that we have the degrees covered, we need to simplify this. So what we're going to do is use mathematical knowledge to get a simpler answer. So we're going to do this by crossing out 90 and 180, and we're going to turn 90, we're going to convert 90 to 1, and 90 and 180 is simply 2. So now we're just going to multiply this across. Numerator to numerator, we have pi radians on the top. And in the denominator, if we multiply this across, we have 2. So now again, let's make this some more readable by using step 3 and simplifying. So we're going to take the radians and put them outside. So we're going to put numerator, denominator, and radians. And you could check this works because when we solved this problem, we got pi over 2 radians, and now we got pi over 2 radians again. So you know that this fraction essentially helps us convert degrees to radians. So how do you convert radians to degrees? Yeah, there is a way, and you would multiply the given radian, just like the given degree symbol right here, the given degrees, 90, by the reciprocal. So we're going to take this fraction that we use, we're going to take the fraction that we use, pi radians over 180 degrees, and we're going to use the reciprocal of that to convert radians to degrees. So let's highlight what we know. We have 3 pi over 2 radians, and we want to get it. Our target in blue is degrees. Right, so let's start with evaluating what we know. So we're going to put down what we have with the given in our equation. We're going to put 3 pi over 2 radians, and we're going to multiply this by the reciprocal of the fraction we used last. So we're going to put the denominator in the numerator. So what we're going to do is place 180 degrees in the numerator and place the previous numerator in the denominator, pi over 2 radians. And you might be asking, why are we using the reciprocal? Well, in converting while using this fraction, we're essentially trying to cross-cancel the unit out. So what we're doing every time is we're taking this unit right here, this unit, and while multiplying, we're cross-canceling it out. So we're gonna cross-cancel this out. And our target unit right here, the degrees, is what's staying. That's why the degrees in this fraction was in the denominator, and we cross-canceled it out to get radians. Now we're trying to get the degrees, so that's why we're using the reciprocal. Now that we know general knowledge, we're going to move on to step 2, which is multiplying. So we're going to take what we cross-canceled out. Hold on, we forgot pi. We're going to multiply this out. So numerator by numerator, we have 3 and 180. So 3 is multiplied by 180 over denominator by denominator, which is all under 2. So using this, we are going to move on to step 3, which is simplifying. What can we simplify? Well, since this is multiplication instead of addition, we can use the denominator to divide from the numerator. So what we're going to do is we're going to take this 180, we're going to divide it by 2. So 180 divided by 2 is simply 90. So essentially we have 3 times 90 and the degree symbol. And we're going to use this to get our final answer, which is 270 degrees. That will be our final answer. We have successfully converted 3 pi over 2 radians to degrees, and that will be 270 degrees. So when dealing with negatives while converting, it might look a little scary at first, but it's pretty simple because you will essentially treat the negative right here like those of a standard multiplication problem. So let's say you're doing maybe, I don't know, -2 times 2. What would you do with the negative? Well, you're going to multiply first, which would be 4. And since this is a negative to positive, we're going to place a negative over. We're going to carry it over. So what if you have, let's say, -2 times -2? What would you do? Well, the negatives, since they're being multiplied together, they would essentially cancel out each other and they would turn to positive. So that's why we have a positive answer and we have a negative answer. Now that we got that covered, let's move on to example 4. So let's highlight what we know. Let's highlight the given. We have -7 pi over 6 radians. And our target unit is degrees. We want to turn -7 pi over 6 radians to degrees. That's easy. We did it in this problem right here. So we're going to use the same fraction right here, the reciprocal of the one we used in example 2. And we're going to start by evaluating what we know. So let's write down the given, our -7 pi over 6 radians. And we are multiplying, remember, put the same unit on the bottom. So you should know generally which right fraction are you using, which right version are you using, because these would have to cancel out. And your target conversion would be on top, so 180 degrees. Right, we have step 1 done. Let's highlight this. We have step 1, which was evaluate. We did that already. So let's move on to step 2. We gotta multiply this out to get closer to our right answer. So like we always do, let's start by cross-canceling this out. We're gonna get rid of the units first. We don't like pi radians in this problem, so we're gonna cross-cancel the pi radians. It seems like 7 and 1, there's nothing you could factor out, so let's just leave those alone. So now we're going to finish the step 2 by simplifying what we did here. We're going to bring down the negative. We have, since it's negative positive, like we did here, it's going to be in our answer. So let's just bring this down. And we're going to do numerator to numerator. We have 7 times 180 degrees. And for the denominator, we have 6 left. Right, So now that we're done with step 2, we've multiplied the problem out. Let's move on to step 3, and let's simplify this out. So again, since this is multiplication, we could divide over, numerator by denominator. So since these two are common and they share a common number, let's divide this and we will get 30 on top. So we have turned -7, we have turned this to -7 times 30 degrees, which is a lot simpler than this. And we're going to finish off this problem by multiplying this out. Remember, negative and positive in multiplication, the negative will be in the answer. So let's put the negative sign first. Now let's multiply 7 and 30. We have 210. And finally, we need to include our target unit in the answer because that is what we were solving for. And that is our answer for example 4. And we have successfully converted radians and degrees with 4 easy examples explaining what you should do in these examples.